yesterday we were talking about Circumcenter and Incenter, and they involved circles quite a bit. So let's go down here onto our vocabulary list and write ourselves some notes, hopefully to help us out a little bit, remembering what is what. So the circumcenter is the point at which three, do we know what goes here? What created the circumcenters? Oh.
Good morning, Red Devil.
All right. Sorry about that. Okay, so once again, we talked about circumcenter and incenter yesterday. So the circumcenter is the point where three whats intersect? Perpendicular bisectors. Perpendicular. Perpendicular bisectors intersect in the triangle. Now, what this created was a whole lot of interesting stuff going on. And so the perpendicular bisectors, I'm going to highlight in blue. You can see the markings on the diagram. We had a bisected segment here. It's cut into two equal parts. We've got the perpendicular. So here, segment MY, segment MZ, and segment XM are the perpendicular bisectors. So M is the circumcenter. Now, circumcenter, there's a circle. There's a circle that connects the vertices of the triangle, like the spokes on a wheel here. From the vertices to that circumcenter, all those pink lines are congruent. All the spokes of that giant wheel with the triangle inside, okay? So again, you should write this down to help you remember later. These pink segments are all congruent, and that's really, really helpful. And this creates a ton of right triangles. So we have the Pythagorean theorem we've got to think about. So for both of these, we have to remember our Pythagorean theorem there. They're going to be helpful for both of these, because we get lots of right triangles. We also had the incenter. The incenter was the point at which three angle bisectors intersect in the triangle. Angle bisectors mean I'm going to the angle, I'm going to my vertice, and I'm bisecting it, creating two little baby angles that are congruent. And at each triangle vertex here, we're bisecting that vertex angle. So these three lines are the angle bisectors. Now, what that created was it said, hey, the incenter had an inscribed circle. We were equidistant to the sides of the triangle, so we get a circle on the inside. So these three pink lines are all the same length. That's that circle, the radius of a circle on the inside. So those three pink lines were congruent. But also, this one created tons of little pairs of triangles. So when we look here, we have two triangles. Each pair of triangles at a vertex, those triangles were congruent. We had congruent angles, we had the right angles, and we have this, the radius there of that incenter circle, creates congruent triangles by angle, sides. So we got a ton more congruent segments, okay? So like this, if BX was a 5, what's BY? Also 5, all right? And so we get all these pairs of congruent sides as well. Again, this is a cheat sheet coming up, all right? The more you can write on here, the better off you'll be. And maybe I'll just let you use this on your test. Who knows? All right. So we're going to continue working with the circumcenter and incenter. So we're here on 5.3, day 2. So again, just putting together what I think are pretty complicated. There's a lot going on with circumcenter and incenter, all right? So we're going to keep this straight. First of all, reading is priority here. We have W is the circumcenter of triangle QRS. What creates the circumcenter? Perpendicular bisectors, okay? I want to know that because I need to mark up my picture. So important here. Perpendicular bisectors of the sides of the triangles, which means U is a midpoint. We have congruent segments on either side. That segment got bisected. I have a perpendicular line here. Here is my perpendicular bisector in blue. All right. If RU is 19, what's US? Also 19. All right, mark it. Clayton. All right, we have here WV is again a perpendicular bisector. If VS is 21, what's VQ? Also 21. All right. And again, on this left-hand side, TW is a perpendicular bisector. Oh, which bisects that side into two congruent sides. If the whole thing is 32, what's QT? 16 and 16 on both sides. Again, as we go around the picture, fill these things in. Make the markings because it makes life easier. Now, when we have that circumcenter, that is a circumscribed circle. There's a circle around through those three vertices, all right, which means the spokes, like on a wheel, those all have to be the same length. So all these pink lines are the same length. What are all the pink lines? Yeah, we've got this 24 marking here, so these are all 24. Really, really important. Okay, let's look here. It's asking, what is RS? RS is this whole side. What is that whole side? 38. And again, we took the time to mark our pictures, took our time to think through these things. It's going to make filling this out a little bit easier. TQ is 16. We've already answered that. WS. WS is my pink line. What is it? 24. Equals 24. It's pink. 24. All right. QV. 21. I don't even see QV. Oh, right here. There's QV right here. 21. We already knew that. Now, TW. TW is where? TW is right here. It is this perpendicular bisector we're trying to find the length of. So this is what I'm trying to find right here, putting a little question mark on it. How do we figure out that TW segment? A squared plus B squared. Yeah, it's a right triangle, so the Pythagorean theorem. So that's, where's the hypotenuse? 24. 24 is the hypotenuse there. So we're going to have, I'm going to just do TW squared plus 16 squared equals my 24 squared. So this is a right triangle. Figure out what the hypotenuse is, and then it's pretty easy to set up. Okay. So let's see. TW squared. It's what is 16 squared? 256. Yeah, 256. And 24 squared is 476? I was so close. 576. All right. And so then what do we need to do? Minus the 256. All right. So we get TW squared equals 320. And then we need to square root both sides. So we have the square root of 320. So TW is approximately 17.9. 17.9. Again, we would round to the tenths place. So the neighbor to the right tells me to round up that 8 to a 9. Okay. Let's move on to let's do 8. Let's do 8. Again, the directions are key here. We really need to understand what we're looking at. It says P is the circumcenter again. And if we have a circumcenter, what creates that circumcenter? Perpendicular bisector. So perpendicular bisector. So PE is a perpendicular bisector. PF is a perpendicular bisector. Mark your pictures. And DP is a perpendicular bisector, which means the spokes from the circumcenter to the vertices are all congruent. Whoops, Daisy. I missed that line. Okay. So these pink lines are all the same length. We want to find AP. AP is right here. What did you say was? Yeah, so they're telling me we have this pink line has the length of 11x minus 14, and they're telling us that this pink line was 6x plus 1. We know that they're congruent. All three of these pink lines are the same length, so we can set them equal to each other, so 6x plus 1. We can go ahead and I'm going to subtract 6x, so that gives me 5x's minus 14 equals 1. And then we can add 14, so we would get 5x equals 15, x equals, whoops-a-daisy, 3. Am I divided by 5? Are we done?
No.
No. What do we have to do?
Plug in into the 11x or 6x.
Yeah, either one. We got to plug it back in to actually figure out the length. This is only the value of x. It's not the length of the segment. It's just the value of x. So we're going to plug that back in. So 6 times 3 plus 1 would be 19. Okay. All right. Questions on that one?
No.
All right. Let's look at number 9. Again, we have P as the circumcenter. And so again, I'm going to start with that's formed by perpendicular bisectors. So PE, perpendicular bisector. PF, perpendicular bisector. DP, perpendicular bisector. My job here is to find DP. DP is this length right here. I'm going to highlight it. Find DP. DP is this highlighted little perpendicular bisector right there. That's what we're trying to figure out. What do you think we can do?
So can we do 8x minus 52?
Yeah. So is equal to, oh, wait a minute. Is equal to 39?
No, 2x.
Ah, okay. So these two segments are congruent. So 8x minus 52 is congruent or equal to 2x plus 14. So this can help us figure out x, which will plug in and help us figure out a leg. So let's see, I'm going to subtract 2x. That gives me 6x minus 52 equals 14. And then I need to add 52. So we get 6x equals 52, 68? 66, thank you. 66. Divide by 6, we get x equals 11. All right. So what should I do with that 11? Plug it in. Yeah, let's plug that in. 2 times 11 plus 14. 22 plus 14 is 36. So we get 36 for this side length AD, but also the side length DB. They have to be the same. They're both 36. All right. What else do we know in this picture?
39.
All right. So PC are the spokes of our tire here. That's 39. What else is 39? PB is 39. Good. And AP is also 39. All three spokes of our wheel are 39. We're trying to figure out this side right here, DP. Do you see a triangle? Yeah. We have the right triangle right here. Maybe I'll highlight it. Highlight it in green. Right there. There's our little right triangle. And so we can say, hey, DP, legs squared plus legs squared equals our hypotenuse 39 squared. True. All right. So DP, whoops, squared, let's see, 36 squared is 1296, and 39 squared is 1521. And we can subtract. Yeah. 1521, whoops, 1521 minus 1296. We get DP squared equals 225, and then square root. So DP equals 15. Great, that's what we were trying to figure out. Questions for me? Okay, turn the page. All right, now we are again practicing with incenter. Again, reading is key. What creates incenters? Angle bisectors. All right, very important. Angle bisectors. So KP is bisecting our angle. We get two congruent angles up there. JP is bisecting our angle. We get two little congruent angles. Again, are you marking your picture? Mark it up. PL is an angle bisector. We get two little congruent angles right there. Now, an incenter means there's a circle inside the figure. There's a circle inside, so we have three little radii that are congruent. PN, PO, and PM are all how long? 13. They're all 13. 13, 13, 13, okay? Really important. And with the extra special thing, we get a whole lot of congruent little triangles here. So I have all these little pairs of triangles at the vertices that are congruent. Why are they congruent? Angle, angle, side. Angle, angle, side congruence here. Which means we get little sides. 30, and over here would also be 30. And that happens, we have three pairs of these congruent triangles. So we get lots of little congruent things going on here. All right, so let's see if we can answer some questions now. The measure of angle MJP. MJP. This angle right here. 39. Also 39 degrees. Because we bisected those angles. The measure of angle JKL. JKL. That's the whole big angle K here. What are we going to do with that?
30 plus.
What's this angle right down here? 28 as well. Okay. And so what is the whole angle J? 78 degrees. 39 plus 39 is 78 degrees. What is the whole angle L? Yep, 56 degrees. The whole angle L is 56 degrees. Can we figure out the whole angle K? Yeah, how? Subtract from 180. 180 minus 78 minus the 56. So we're subtracting the whole thing. We get 46 degrees. For the whole angle K, is that what we wanted? J, K, L. We wanted the whole angle. So that's 46 degrees. Then it says, hey, what's the measure of angle in KP? In KP is just this angle right here. Just that little one. What's that one?
33.
What is it? 23. 23. Okay. 23 degrees. How did we get that? Yeah, 46 divided by 2. The whole thing split into 2 equal parts. All right. And then KLJ. Let's see. KLJ. Ooh, we already know that. KLJ is the whole angle L there. We said it was 56. All right. NP. 13. That's those pink lines. They're all 13. KM.
30.
Yeah. KM, we already said those triangles, those yellow triangles are congruent, so our little sides are the same. So that's also 30 there. 30 and 30. All right, and then let's find KP. KP is this right here, that length there. How do we figure out that green length? Pythagorean theorem, yes. It is part of a right triangle here, and we're trying to figure out KP. KP is a hypotenuse. So 30 squared, the leg squared plus the 13 squared equals KP squared. It is our hypotenuse we're trying to figure out there. All right, so 30 squared plus 13 squared is 1069. And then we square root that. And so KP is approximately 32.7. All right, questions on that one?
No.
Do you feel okay with this?
Yeah, I think we're ready.
You think you're ready? I think we need to do one more here. Let's do 20. Again, number 20, we are dealing with K being the incenter, the incenter. So again, I need to mark up my picture here. The incenter is created from angle bisectors. So my angle here, angle E, gets bisected. So EK is my angle bisector. Angle D gets bisected. Angle F gets bisected. And when we do that, we get an inside circle, which means all those little radii, my pink segments here, are congruent. So what can we do to set up an equation here?
3x plus 17 is equal to 7x.
Yes. 7x minus 31. Again, these are the little spokes of my wheel here. They have to be the same length. So I'm going to subtract 3x. That gives me 4x minus 31 equals 17. Then I'm going to add 31 to the left side. That would be 48.
And then that gives you x equals 12.
Okay, and we're not done.
You plug it into 3x plus 17.
All right, so KI is another pink segment, so we can plug it in to either of these places. So KI would also be 3 times 12 plus 17. Good. Well, that one was pretty easy. All right, do you have any questions for me?
No.
All right, It's a lot to process, ladies and gentlemen. You need to make sure you're keeping it straight. All right, little worksheet today.